Hi guys. Can you guys hear me?
Yes.
Yes, we
Go ahead.
Yeah. So hi guys. So welcome to another session of Bootcamp to 2020. So today we are going to discuss EFS and Cdk testing. So Huma with hello.
Yes,
I
yes,
think
go ahead.
there's
No, you are there. Huma, why don't you go ahead and start with Elastic
okay.
File System?
Okay, sir. I am starting to share my screen. Sir, can you see my screen?
Not yet.
not yet.
Okay, you can let me know as soon as you can start. What about now, sir?
No. Now, yes.
Now? Okay. Okay. So Elastic File System is a file system to store your data. Just like we have file system in our laptop, we have Elastic File System to store our files and data. What's great about Elastic File System is if you have a, a service which actually want to read and write data, but it's in different availability zone, you can connect that to Elastic File System, and you can connect multiple sources to one Elastic File System. All you need to do is mount that service to the file system, define the path where that file or where that service, either it's EC2 instance or Lambda, where it can write, and you are ready to use Elastic File System. Right now in this CDK code, we have start with VPC. Let me touch upon what VPC is. I have actually prepared few slides in order to understand the basics of VPC, but for understanding this CDK code, VPC is Virtual Private Cloud. Now there are two types of cloud: private cloud and public cloud. Private cloud is having your data center with all the networking done by yourself, completely secure on premise. Uh, Public cloud is like having a cloud where resources are shared among different users.
Huma, we are not seeing your slide.
Okay, you can hear me?
We can hear you, but what we are seeing is
I can hear you fine. Can you hear me fine?
Voice is fine. What you are seeing is your code, not your slide.
Yeah, but I'm not showing my slides yet, sir.
Okay, sorry.
Okay,
Sorry.
I'm actually trying to cover Elastic File System. It's very easy, and once I'm done with that, I'll move on to slides. And in the slides, I actually have tried to explain VPC, the introduction of what VPC is, but I'm just giving the overview in few sentences so that I can carry on with my file system. Okay. So VPC is your virtual private cloud where you can define your networking. You can make it highly secure by configuring services and their security rules. Up until now, we have used some services which were like pretty straightforward to use. Just define the service and start using them. But starting from this service and few services which we'll cover in future, they are called VPC only services. They are related to your data, and AWS enforce you to define the VPC, the securities, the entire networking, so that you can make your data highly secure. Okay, so this service will not be created until and unless I define my VPC. So by default, when we create an account, we get a VPC in every region. Let me show you. This is my account, and currently showing that I have one VPC. But see, all regions, I have one VPC per region. So as soon as I create account, I get my VPC, and whatever resources we have deployed so far, all of those resources actually go in this VPC without us knowing that what is happening. But all those resources are deployed in this default VPC which we get when we deploy our account. This is my VPC. I have not deployed anything yet, but this is my VPC. You can see there is no name over there. This is default created by AWS for us so that we can start using those services, learn with them, and then as soon as we reach critical point, which we have reached, that we are using more and more of different data systems, so we are enforced to use VPC. So I've created a VPC. Simply creating a VPC will not make it secure. What I have done is simply created a VPC and mentioned that my file system will be on this VPC. This is not secure. Since I'm not providing anything, it is taking up the default configuration, and the default configurations are not secure. They are open to the world, and you can access them from anywhere. It's not secure. It's a means of making things secure, but right now it's not secure. So I have created new EFS file system, elastic file system, and I have actually downloaded and imported that EC2 for my VPC and EFS for my elastic file system. All it needs, which is mandatory to provide, is VPC. All the other attributes or configurations are optional. So I've provided my VPC, my elastic file system is created. Now what? In order to access the file system, I need access points. I can make multiple access points and assign those access points to different services. For this, for the sake of this CDK example, I have created one access point. This is how I create access point file system dot access point. And I have to configure this. This is, I'll touch upon this in a moment. And I have created a Lambda, and I have attached that file system Lambda access point. So now let's see what's in the access point. The very first thing is the path. But whatever my Lambda will write in this path /export/Lambda. So that if I have multiple sources attached to file system, they all can write in different files or in the same file. So I have provided the path that this Lambda will write in this file, in this folder. Permission, this permission means that I am giving this access point read and write both permission. I can give either read or I can give both. This user ID and group ID is something which will provide added security. I can give any arbitrary number, 1001 is not necessary, and this will actually define that my service which is actually accessing file system is allowed to access. Now I have my Lambda, runtime, code, handler, everything is same. One more thing, in order to access resources inside a VPC, my Lambda has to be in that VPC. For that reason, I have configured VPC, my VPC. So my Lambda is not in default VPC. My Lambda is in the VPC which I have created over here, this one. So now it can access the resources inside the VPC. In case of residing outside this VPC, I would have to configure rules so that this Lambda can talk to resources in other VPC. For the sake of ease, we have put Lambda within the created VPC, so I do not need to define any rules. It can straightforward contact the EFC system, access the resources. And then we have API for our Lambda function. Now let's move to what we have in Lambda function. This code is available in the repository. It's simple, nothing special that I need to define. I have actually changed it so that I can make it easier to understand. I have importing file system. This is the file system. This is a path I have actually provided where I want my file to write in the file system. Now I have two functions, create message. What this function is doing is actually appending the file in this path. Now I do not need to import SDK and define this construct so that I can access, because I have mounted my file, my EFS file system with Lambda. So it behaves as like connected. I do not need SDK to call the particular specific service and create a client and all that. Okay. And in the second function, I am getting the message, whatever I have written there. So as soon as I'll invoke the Lambda, this Lambda will write a message and then will get the message and return it to me as an output for the Lambda. Create message, hello from Lambda, response, get message, and then it will output the message. Sir, is the stream going fine? Am I stucking or not?
Yes, go ahead. Over.
Sir, I have two options. Either I will deploy the code and trust me, it will work fine. Or should I move on with VPC?
First of all, why don't you revise this code?
Okay, sir. Okay. So this is my CDK code. I have downloaded Elastic File System and EC2. I have called EC2 because I need to create a VPC. So I will create an instance. That VPC is actually running on that instance. So this is my VPC. I have provided my availability zone 1. I can provide it more than one, but for the sake of ease, I have provided one availability zone. I need this VPC because file system cannot be deployed without mentioning what VPC it is in, all because of security reasons. The other three options are encrypted. This is for encryption. Lifecycle policy, just like we did with DynamoDB, that what should be the retention policy, should it be destroyed as soon as the construct is destroyed or not. So this is lifecycle policy. There are different kind of options you have, and then performance mode. I actually do not need any of this for this code. Access point, this file system can be attached, can be mounted to multiple sources, numerous lambdas, so many EC2 instances. They all can write and read at the same point. They all can access the same common file system. So I need access point, and that access point needs some rules. The important part is your path. I can define either same path so that all can read in one file, or I can define different path and different access point rules for every other service. This is right now I'm having only one access point service because I have one lambda. Let's say I want 2 to 3 lambdas to write in the same file system. I can have different for each lambda, or I can use the same for all of them. Permissions, you can change permissions. Right now this permission 750 means that this lambda, this access point which I will mount to lambda, have read and write permissions. And then I have lambda. In order to access resources inside the VPC, I have to put my lambda inside the same VPC so that I do not need to configure special rules. Right now I am keeping it inside the VPC, so it's easier for them to communicate with each other. They are in same VPC, they can access each other. The resources from outside can also access resources from other VPC, but for that I will have to configure the rules, and right now I'm not configure the rules because VPC in itself is a big topic. And today we will cover the introduction, and in the subsequent classes we will build upon that knowledge so that it would be easier for us to understand. I'm mentioning the file system. I'm actually mounting this lambda to this file system. So now this behaves like one unity. I do not need any special configuration to tell my lambda where to go. I do not need to import SDK code in my lambda code function because now I have mounted that file system in my lambda's file system. So lambda.file system from EFS access point, and here I've mentioned my access point, the rules which I have defined right above here, this one. Okay. And then I have an API for my lambda in order to access the lambda HTTP. Okay. Done, sir. Now I am moving on to the VPC.
Okay, go ahead.
First of all, this is highly abstracted, overly simplified view of what VPC is, so that we can understand in baby steps. I'm trying to zoom in.
Mm-hmm.
Not sure why it's not working. Oh God. This is all I can do. I don't think I can zoom it any further. So,
okay.
A virtual private cloud is a logically isolated virtual network. You can have multiple VPC in one region. What do we get when we deploy, when we actually deploy our resources inside VPC? They actually isolated our resources. Let's say I as a developer have 2 applications and I need to deploy both of them in my one account, in my single account. So I do not need to have another account so that they service both of these applications can stay isolated. I can make up a VPC for one service, one application, and make up another VPC for other application. They can protect your instance from network intrusion. The default VPC we get from creating an account is not secure at all. They have defined it in such a way so that we do not have to configure special rules, and we can access any service. We can also access internet. Any service on anyone on the internet can actually easily access our services. They are not protected by default. We have to protect them by configuring the rules. In order to understand VPC, we need to understand these 5 to 6 things. CIDR block, which I'm not going to talk about today in order to make it simple. Subnet, gateway, route table, network access control list, and security group. Now these are more than half of them are actually related to networking, and it takes time to understand them. All I'm trying to do is make it simple as an introduction so that you may absorb it one at a time. There are few rules. A region can have one default VPC, not one VPC. One default VPC will stay there, which is actually made by AWS for you, there can only be one default. The other will be custom made by you. You can have 5 VPC in one region. This is a restriction. Every VPC is associated, again, technical stuff. All these points are very
important. Students are complaining you are talking too fast.
Okay.
You have to slow down a little bit.
Okay. So the main part is going to start from the next slide.
Yeah.
These are the rules. You can find them anywhere in the document. What I have worked upon is having a simplified view of what each of the different things are. For now, there is one restriction that you can have up to 5 VPC in one region. All the 3 steps are very, very, very important, but I'm not going to touch them today so that you can understand it as it's very easy. So this is my AWS account, and this is my default VPC. For the sake of understanding, this is my default VPC. What we have done until now is what we do. We pick up S3 bucket, deploy it, pick up DynamoDB, deploy it, any other service like SNS, deploy it. Actually, they all are deployed in our default VPC without us knowing that it's deploying inside the VPC. Okay, so simply having VPC is not secure. As I said, it actually gives us control over our cloud and make networking so that we can make our application more and more secure. So this is how we used to do before. Just deploy everything, and all of those services are deployed in our default VPC. Now, subnet. Again, this is something related to networking, and I'm not touching the technical stuff. I'm just trying to make it easy. What are subnet? You can divide your VPC into smaller groups. Those small groups are actually called subnet. So let's say I have one VPC. I can divide that VPC into 2 smaller groups. I can give one set of rules for one subnet, other set of rules for other subnet, so that I can decide which subnet I want to be more secure and which subnet I want to leave less secure or maybe open to the outer world for our user. This is how my AWS account, my VPC, and I have created 2 subnet. Okay. Now, when we get a default VPC, we get one subnet per region. Let me explain it. Let's say I have deployed my VPC. I have created my account. So I have one VPC in every region. Let's say region A has 3 availability zone. Let's say region A have 3 availability zone. By default, I will get one subnet in each availability zone. If a region has 2 availability zone, I will get by default two subnet in each availability zone, one in each. This is how AWS works. Currently, the region I am using, I get 3 subnet because I have 3 availability zone. For the sake of this example, I am using 2 subnets. So let's assume that I am having 2 availability zone in one region, availability zone A, availability zone B, and I am talking about default. I can make more than that. I get subnet 1, I get subnet 2. So I hope it's clear that what VPC is, your virtual private cloud, your isolated cloud, so that it's not connected by any other user. No user can intrude, no network intervention. In order to divide that VPC into smaller groups, I have subnet. I can make subnet. Again, I'm not telling you how to make subnet, how to do IP addressing, how to do CIDR, private and public networking, nothing. Just simple VPC subnet. We have to do all that in order to make our application secure. Gateway. For communication with the internet, VPC must be attached to an internet gateway. Again, internet gateway is a networking stuff. In order to communicate with internet, you need internet gateway. In our case, internet gateway is a service which is provided by AWS, bidirectional source. There's a definition right there. A subnet, let me show you the definition. So when I have an account, I have a default VPC with few subnets, one in each availability zone. I also get an default internet gateway. That is the reason we were able to communicate through internet when we assign any IP to our Lambda, or when we have a website bucket and we have IP for that. So we do get a default internet gateway, and by that we are able to communicate or can make connection with the internet. Now, if we have an internet gateway, we do get a router. We do get a router, implied router. Well, in networking, router is like something hardware, but in this case we get a software which is router. We have two subnets, and we have a router, and we have an internet gateway. In order to decide what traffic to divert where, we actually need route table. Based on that route table, router decides where to divert the traffic. So every VPC is attached to an implied router. As we get default subnets, default internet gateway, we also get default router, and router actually reads the route table and directs the traffic. This router is not visible to users and is fully managed by AWS. The route table is associated with each subnet. So route table is actually associated with subnet. You will associate a route table to subnet, which is used by router to determine where to divert the traffic, inbound or outbound. Every route table have a default route. I'm trying to make it simple. The very first line which actually has an IP address and local. What does that mean? This is default configuration, and that means every traffic from within the VPC. This is the IP address of my VPC. Let me show you once again. For this example, the IP address of my subnet is 172.31.1.0/20. The same with here is 172.31.2.0.20. Again, making it easy. This actually resembles or signifies that they both are my subnet. If a traffic is coming for subnet, route it to the local network. This is local network, and they all are allowed to communicate with each other. I'm trying to make it simple that this one configuration, this first line means that inter VPC subnet, inter subnet communication is allowed. The other the rule in the table states that if it's 0.0.0/0, it means I am talking about any IP address out in the internet. If I get any request for accessing internet, direct that traffic to internet gateway. So all non-local addresses should be directed to internet gateway, and all local addresses should be routed locally. This is default. Again, this is default. In order to make it secure, we should define the route tables. For this default setting, subnet 1, subnet 2, they both have same routing table, and the routing table is saying that if we get traffic from within the VPC across the subnet, route it within the VPC local subnet, and it's allowed. If we get a traffic for internet, direct it towards the internet gateway. So with the help of second rule, I actually am able to communicate to the internet. Let's say if I decide to make subnet 1 private, so nobody from the internet can access it. All I need to do is not define the second rule. So now this route table is stating that my subnet 1 and subnet 2 can communicate with each other, but my subnet 1 cannot actually communicate over the internet. So this routing table is very important in order to define rule, and routing table actually belongs to subnet. Then we have network security. All default subnet in default VPC are public and open, as I said again and again. Default configuration are not made secure. AWS provides security mechanism for your instance. Now you have two security layers. One is called network access control list, and the other is called security group. Network access control list behaves as a firewall over the VPC or the subnet. You can use network access control list and define rules so that you can define security rules for VPC or subnet or both. Security group act as a firewall or security layer for instances or services within the subnet. So I have subnet 1. I can attach NACL. That NACL will contain some rules. Now traffic will be directed to this subnet in and out, filtering by those rules. So now I have my account, my default VPC, subnet 1, subnet 2, each in one availability zone. They both are connected to router, but they are going through NACL security layer. So this security layer, they can have few rules which can make my subnet 1 or 2 both even more secure, because now I have defined few specific rules. Only if the rules apply, the router will direct the traffic wherever I want to go. Security group, as I said, security group act as a firewall or security layer within the subnet on instance level, or you can say on service level. Let me not touch the technical stuff again. So I have subnet 1. My subnet is actually connected with NACL, defining rules for security, but I can have one more security on my instance, and this instance is actually containing DynamoDB. So this is my service DynamoDB, and I can define security group on the DynamoDB. And once a traffic going through that rules, applying those filters, will be allowed to access DynamoDB. So now I hope everything is not covered, because NAT gateway is not covered, VPN is not covered, but these are 6 basics. I have my AWS account, I have a VPC. In order to divide my VPC into smaller groups, I have subnet. In order to connect with the internet, we have internet gateway. Definitely we need a router so that traffic can be routed. I can attach special rules, security rules as a firewall on my subnet. And in order to attach security rules on my services, I will use security group. We have never worked with any of these services, because all we did is use the default services, default security group, default NACL, default internet gateway. We have not configured any of those, and now we have to take charge. We have to learn how to use them, and we have to configure it so that we can make our application secure. In this example, I have DynamoDB in one subnet, my website bucket in other subnet. Now my website actually needs to be accessed from the outer world, so I need both the rules, interrouting for the local and internet gateway for the internet access. But my DynamoDB doesn't need to be accessed over the internet. Only the services within either this subnet or other VPC or this subnet should access my DynamoDB. So I can define the route table that inter-services, local services are allowed, but call over the internet should not be entertained. Similarly, subnet can have individual rules so that we can decide, do we want this subnet to be available on a particular IP address or a port? And the same can be done with the help of security group. We can attach security group to different services and define different rules for our different services. Let me show you a glimpse that this is my default VPC. I got 2 subnet in this North California, but I actually use US East 2. I'm just showing you.
I don't think we can see your screen. You're on the wrong screen. We're seeing your slides.
Still nice. Okay, let me check. Okay, then leave it, because I have to do so many changes. I was actually trying to show my account, but it actually works on Firefox, not on Chrome. So I think that's enough for today.
Okay, thank you, Homa. So that was a very nice and comprehensive explanation about EFS and VPC. So now we're going to move towards CDK testing. I'm just going to turn off my camera because I think my internet is really slow. So can you guys hear me fine? Okay.
Yes, I can hear you.
Okay. So basically, we've been doing testing since the beginning of this bootcamp. So we did testing in the SpaceX project, in the timer project, and I think in a few more projects. So I think if you're watching this video, you must have already completed those projects, and I think everyone who's watching this video must know what testing is. So basically, testing actually gives you a bit more confidence on your application. that it would work just as you expect it to be, and not only to you but to also to those people who are trying to run your application. So up till now we have only done front-end testing that was done using React testing library and Enzyme. Both of them were based on Jest, but for the CDK testing we're just going to use Jest directly. So another advantage of testing is that you can actually run those tests in your CI/CD pipeline. So, and whenever any of those tests fail, your pipeline stops, the execution stops, and the new version of your application that could not pass those tests does not get deployed. So this can be very useful because it can keep your running application from breaking. So this is also a very useful feature of testing that you can integrate it in your CI/CD. So there have been, I think there are two different ways in which you can write tests. The conventional way is to write your code first, your application code first, and then write tests. So this is the conventional way, the easier way. But lately, people have been first planning the application, then writing the tests even before writing the code. So first you plan your application, then you write your tests, and then you write your code that is supposed to pass or satisfy those tests. So this is the new way of writing tests, and I think it's a better way because it gives you a bit more confidence that you're going to cover all the important aspects of your application in the testing. But I think either way is okay as long as your tests are meaningful. So I'm going to share my screen. Okay. So before actually going through the code, I would actually like to revise a few things from the previous class. Now we have already seen this graph. This is basically the structure of your CDK project. Now you need to understand this structure to understand how the testing works in CDK. Now I've already gone through this in great detail in the last lecture. I just want to revise it once again. So as I just told you, that your CDK project is organized in a tree structure. So you can see this is basically the organization of your CDK project. So there are two things to note over here. Number one, every tree structure has a root node. So each one of these boxes that you see over here, you can call them a node in a tree. And every tree has just one root node. And in case of your CDK project, your root node would always be your app, the instance of your app. So this is the first thing that you need to understand, that you just have one root node in your CDK project. The second thing you need to understand is that every node is defined within the scope of its parent node. So what this means is that this stack node is going to be defined in the scope of the app. And likewise, these three constructs would be defined within the scope of the stack, and so on. And so these are the 2 points that you really need to understand. I've gone through them in the last lecture in great detail, but just keep these points in mind. So basically, in the scope of app, you have your entire application, but the immediate child of this scope is a stack. The immediate children of your stack are these three constructs, and so on. But you need to understand that in the scope of this app lives this entire tree, everything. Yeah. And the main difference between the stack and construct is that stack is defined directly in the app, whereas constructs are defined in the stack. Now your application can have more than one stacks if it's a big application, but it cannot have more than one app, more than one instance of your app. And this is where you are normally writing your code over here in the scope of the stack. So this may be your Lambda function. This construct may be your DynamoDB table. This may be your app sync. So this is where you are normally writing your code when you are creating a CDK project. So now let's move on to the code. So I'm not gonna go through these steps that are in the repository because I think they're very, very simple. I've added a few more complex tests and combine them together to make some new steps. So I'll try to upload them in the repository as well. So what I'm going to explain right now is going to cover everything in the repository and plus some more steps. So if I open my CDK project, first thing that you need to understand is that the CDK init command actually creates a bin folder for us. And if you go inside this bin folder, there's a file in it. And in that file, we are first creating the instance of our app. Now, this has already been done for you by Cdk init command. I'm just showing you what it means. So I told you before that first of all, you need to create an instance of the app. So this is what we have done over here. Create an instance of the app. And then we create a stack in the scope of this app. And this is exactly what we're doing over here. Let me just zoom in. And then we're creating our stack. And we all know that the first parameter is the scope. And in the scope, we have passed the app that we just created in the line above. So first we created an instance of the app, and then we created.
Can you please zoom a little bit?
Yeah, sure. I have a bit more.
Yes. Thank you.
So the stack is created within the scope of this app. This is very important to understand. We don't usually go through this code because it is already because Cdk init creates it for us. And now let's have a look at the class of this stack, and it lives inside the lib folder where we usually code. So we usually write our constructs over here in this class. So it is important to understand that this thing over here is the instance of that class in which we write our code. So we usually write our code over here in the scope of the stack. We are creating these constructs. Yeah. So let's go into the class of that stack. Now in this class, you can see for now I have just created one lambda function. That's it. So I should also make the tree over here. So if I can just remove these. So up till now, we have created an app, a stack, and in our stack, we just have one lambda function. So this is our graph right now. Yeah. So now let's run some tests on it. So you will find your test. So Cdk init actually creates one example test for you. You will find that in the test folder. And inside the test folder, you have some test files. And test files are named like this, like the name of the file, .test.ts. And then when you run the build command, it gets converted into JS. So let's go to the TS file. So you can see I have written a few tests over here. We'll go through them one by one. So first of all, let's have a look at some very simple tests. Okay. So first of all, I'm just going to show you the most basic test for right now. That is the snapshot test, and we have all used it in the React as well. So let me just comment everything else. Okay. Now to write your test, what you have to do is you have to use this test function, and this test function. The first thing in the test function is the description of the test. Now, this can be anything, the name of the test or the description of the test. And then the second parameter is another function in which you write your tests. Now you can see this entire thing is my test. Now you can see in this test, I've created a new instance of the app. Yeah. I've done exactly the same thing that was in the bin folder, but I've done it again because it's just a better practice to create another instance of your app for testing, because if you make changes in your main in the app instance of your main application, then you may disrupt your main application. So it's always the best practice to create new instance of all the classes in the test. So I've created a new instance of the app, and then from my lib file, I have imported my main stack over here, and I've also created a new instance of my stack. So this means that when I'm creating this instance, it's creating a lambda function because this stack only has one lambda function. And now I'm ready to test it. This is important to understand that you have to actually initialize it again to test it. It's just a better practice. So now I've commented out everything else. Right now I'm only running one test, that is snapshot test. Now to run a test, you write expect, and in the expect you write your expression, and then you write your condition. So snapshot test does two things. The first thing it does is that it creates a cloud formation template for your stack. And then the second thing it does is that it looks for saved snapshots, previously saved snapshots. If it cannot find any previously saved snapshot, it will just save that newly created snapshot. That's it. But if it can find a previously saved snapshot, it will compare your new snapshot with the previously saved snapshot, and if there is any difference in if there is any difference in them, then it's gonna fail the test. So that's how this snapshot test works. I'm pretty sure everyone knows about it because we've used it a lot of times. So what I'm saying over here is that I'm using this synth utils that I imported from AWS Cdk/Azure, and this allows me to use a function that can create a CloudFormation file. And I want to create a CloudFormation template of what? I want to create a CloudFormation template of my stack. And then I'm saying I want it to match snapshot. So this function, basically what it does is that it actually looks for previously saved snapshots in your directory. If it cannot find any, it will just save this new snapshot. But if it can find any, then it will compare it with the previously saved snapshots. You can also read the documentation over here. This ensures that a value matches the most recent snapshot, the one that has been saved. So right now you can see in my test directory. So snapshots gets saved in the root directory of your tests. So you can see in this test directory, I do not have any test right now. So let's run this test. Now to run this test, you write npm run build and npm run test. Now, right now, because I don't have any snapshots saved, oh, gave me an error. Oh, I forgot to save it. Let's try again. Because I don't have any snapshots saved, it will just create a snapshot and save it, and that's it. And you would usually use the snapshot test where you want to change something in your code, but you want to make sure that you do not change anything in your CloudFormation template. So you can see it says one snapshot written. And you can also see the snapshot over here. It got created in my test directory, and the snapshot looks like this. It's like a CloudFormation template. Now, whenever I run the test again, it will now compare my new it will create a new snapshot, and it will compare it with this snapshot, and they should be same for the test to pass. Now let's run it again. Now when I will run it, it will not save it again. It will just compare it with this saved snapshot. Now, because I've not changed anything in my CloudFormation template, it's going to pass. Yeah, but let's try changing something in my stack. Now, if I go to my stack again, if I so much as just change this name, now the CloudFormation template that's going to be formed now is going to be different from what is saved. So it's going to give me, so the test is going to fail. Let's see. So basically, if I had mistakenly changed something in my stack, then I would immediately know that, okay, my test failed, something went wrong. Yeah. Now, if I want to deliberately update my saved snapshot, like if I want to deliberately change something in my CloudFormation template, then I would also want to update my snapshot. So what I can do with that, in that case, I can run this command, npm test uu. Let's run it. --u. Now, what this will do is this will update the saved snapshot with my new CloudFormation template. So now the previously snapshot that was saved had this name for this ID for the Lambda function. Now I've updated my snapshot. Now the snapshot that would be saved that would have a CloudFormation template with this ID for this Lambda. You can see it updated my snapshot, and now when I will run the test again, it should pass. So this is the very basic snapshot test. Yep, passed. Okay, now let's move on. And so the first step in our repository is revolves around this test. It's a very basic one. I'm just going to comment it out again. Now let's move towards something more interesting. Now in my stack, what I can do is I just have one Lambda function. So what I can do, the first thing I can do is I can actually look for resources. I want to make sure that my Lambda function got made in my stack. Like I can have a look at my resources that were made inside my stack. So to do that, you have this tag which is more specific to CDK. And here you will write expect stack, this stack that we just initialized, to count resources. And what kind of resources? I'm saying I want to look for AWS Lambda function. And how many am I expecting? I'm expecting just one Lambda function in my stack. So, and that's true, right? Because we just created one Lambda function. And this test should pass because we just have one Lambda function. And let's see if it passes or not. Let me just delete this folder. It's failing because it's saying that you have a snapshot saved, but you don't have a snapshot test. I'm just going to run it again. Oh, I forgot to save it. Now it will go through all the resources in this stack, and it will look for this type of resource, and will then confirm the number of resources that it will find of this type. So you can see it passed. But if I write 2 over here, it's going to fail. Why? Because our stack only has one Lambda function, but here we are saying we're expecting 2 of them. So it's going to fail. The test would not be satisfied. Let's see if it returns how many Lambda functions are really in our stack. It should return over here. As you can see, it gave us, it said that the test failed, and it's saying stack only has one resource of type AWS Lambda function. So only this would work. So this is how you can actually verify that your resources are being made inside your stack. Now this is okay, but if you want to be a bit more specific, you can use to have resource function. Now you can have like right like this. You can have like many different functions, but I'm just showing you which are more important, which are more CDK specific. So if you use this function, then you can again mention that what kind of resource are you expecting. You only have a Lambda function, but instead of counting it, we can specify the properties that are associated with this Lambda function. So it's going to look for all the resources. It's going to say, okay, there's a Lambda function in this stack, but does this Lambda function have these properties or not? It's also going to look at that. So if I go to my stack, you can see my Lambda function has these properties. I have a handler called index handler and memory size 1024. And that is what I've mentioned over here. So it should pass. So it's passed. Now, if I change anything in the properties, like if I make it 102, it would fail because it would contradict with the properties of my Lambda function in the stack. It's 102 for here. I've made it 102. That's what happens now. It should fail. This is like a more fine-grained test for your resources. Like if you have 5 Lambda functions and you want to make sure that that one Lambda function with these parameters is there or not, you can do it like this. So you can see it failed, saying it doesn't have, you don't have any Lambda function with this memory size. So these were some very simple tests. Now let's make things a bit more interesting. Now in my main stack, I just have right now I just have one Lambda function. Now let's say that I want to add a function over here. Right, so now we have also seen this function in the last class. I've been through it in great detail that how does it work. But let me just go through it again. So this function basically add tags to everything in this scope. And by everything I mean not only the immediate children, but also the grandchildren, and everything else in the scope. Like not just the immediate children, but everything, even the grandchildren. So this is important to understand. So I'm saying I want to add tags to everything that is in the scope of this tag. And what are the tags? So you give tags and key value pairs. This is the key. I'm saying that the key of the tag should be hello and the value should be world. So it's going to add tag to all the resources in this stack, in this stack with this tag. And right now we just have one Lambda function. Now I've added this function, but I want to make sure that this function is working or not. Like how would I know that if it's working or not, if it's being executed or not? Now one way is to actually go through all the resources. Right now I just have one, but you can go through all the resources and see if this tag got associated with them or not. One way is this, which is which is very hard to do in CDK. It's not impossible. It can be done, but it's hard to do, so I'm not going to go through it. The other way is to mock this function. And what do I mean by mock this function? Let me show you. So this brings us to our second test. Now, keep in mind that our main aim, in the first test, we tested whether lambda function was there or not, whether the properties met or not. But now we don't care about lambda function. We only care about this function, and we want to see if it's being executed or not. Now, to do that, again, I created an instance of my app, and before creating the instance of my stack, what I've done is I've written jest.spy on, and spy on what? Spy on cdk.tags, which is the module of this function. So this function comes from cdk.tags. So over here, the first parameter is the module, and the second parameter is the function that you want to mock. Now, what do I mean by mock and what do I mean by spy on? So basically, when you write this function, what it does is that while your code is running, while your stack code is running, whenever it will get to this function, the one that I mentioned over here, it will replace the original function with a mock function. So what do you mean by that? So the original function is basically adding tags, but because I've mocked it, with now instead of running this original function, it will run a mock function. And right now, this is our mock function. It does nothing. It doesn't add any tags. It doesn't do anything. Although you can actually add a body and a return value for your mock function, but we don't need it right now. So basically, your original function would be replaced by a mock function. But what is the advantage of that? The advantage is that you would be able to trace it. You would be able to tell it how many times did it run. And how many times do we expect it to run over here? We just expect it to run once. So you can see I've set my mock function to be called times 1. Why? Because we are only running it one time. Now this can be a bit confusing. Let me revise it. So whenever you mock a function, the real function is replaced by your mock function, and the mock function by default does nothing. It literally does nothing. But the advantage is that you will be able to trace it. You would be able to tell that how many times did it execute, and therefore you can actually tell that how many times this original function was intended to execute. So this can be very useful. But you can also add like a body and return value for the mock function. Then this function would actually replace the original function. But right now we only care about whether it ran or not, and let's see if it works. So I'm saying over here that I'm expecting it to run once because the function that I've mocked was intended to run once. So let's see. Oh, I forgot to save again. So you can see it passed. Now what I can do is I can actually add it once more. Let's say I added tags twice. Now this should run 2 times. Because every time that this function, this real function in my code would run, it would be mocked by a mock function. It would be replaced by a mock function. And what is the advantage of mock function? We are able to trace it. We can actually tell that how many times was it called. Let's see. Yeah, it passed fine because it's now running 2 times. So this is the second kind of test that you can do if you have these kind of functions in your stack. Now moving on to the next test, let me just comment it out. Now what I can do is I can create, now let's say that I want to create a custom construct and then initialize it in my main stack. Now let's see how can we do that. Now we created a custom construct in the last class as well. So I've already created it over here. So in the my construct folder, I've created a my construct file. So it's a file that extends cdk.construct, and it has a property handler that is of type lambda function. And in this property, I'm creating a new lambda function. That's it. So this my custom construct just has one property called handler, and in that handler we have a lambda function. And this custom construct also has some props. It is also expecting some props. So the type of props is this. It's expecting a function name. So and I'm passing that function name from props to over here. So this function name would come from the props, and this construct would just create one lambda function. And what I can do is now is I can actually import this over here in my main stack. I've already done that, and initialize it. So new my construct, and this is the scope. So yeah, now you can see I've created a construct over here as well in the stack with this ID and passed the props, which was the name, and there was only one prop that was the name of the function. So I passed it. Now what is important to understand is that how does our tree look like? Now we have one lambda function. This is our lambda function. Just change the name. And we have our custom construct. And in that custom construct, we have another lambda function. This is important to understand. But when we're testing your application, you need to know that which resources are in which scope. So you can see now our tree looks something like this. In stack, the immediate children of stack is the immediate children of the stack are lambda function and my custom construct, and the immediate child of my custom construct is a lambda function. And this is how our tree looks like now. Now let's do some testing over here. So you can see we have one lambda, so I'll just comment this out. So we only have one lambda function and one custom construct in our main stack. And inside this custom construct is another lambda function. So if I go back to the test, now again we have initialized our app, and then we created our stack within the scope of the app. We did this in the test. Now, okay, there are one by one. Now you can see I'm saying that expect stack to count. This is the same function that I use in the first test that counts how many lambda functions are there. So you can see this is a bit weird that I'm saying in this stack count resources type lambda function, and I'm expecting 2. But you can see in my graph the immediate child is only 1. This also is in the scope of the stack, but it is not an immediate child. So basically this function actually says that I'm going to find resources. I'm going to look for resources not only in the immediate children, but also in the grandchildren and grandchildren and everything. So this function basically says that I'm going to look for resources in everything, the entire tree below the stack. Yeah, so it's going to look for lambda function. So it's going to find one lambda function over here, that is the immediate child, but it's going to find the other lambda function over here, that is the grandchild of stack. So this is important, really important to understand that how these testing functions work. So this should work fine. So let's run it. Let me show you once again that you can see in your stack you have just created one lambda function. This second lambda function is inside this construct. But because this function goes through all the resources, not just the immediate children, it will find 2 lambda functions. You can see it passed. Now let's run another test. This test did nothing. It just told us that we have 2 lambda functions. We have 2 lambda functions running somewhere inside our stack. We don't know if they're immediate children or where are they. We don't know yet. This test doesn't tell us. This test does just tell us that you have 2 lambda functions somewhere running below your stack. Now, if I want to be more precise, I can say that okay, stack dot node dot try find child. Now this function looks for resources only in the immediate children. So this function that I showed you, try find child, this will only look in the immediate children of the stack, only over here. It will not go over here because it's not the immediate child. Only these 2 are immediate children of my stack, my custom construct and the lambda function that is made inside the stack. So this function would say, so in this function actually requires an ID. So it's saying so basically we write stack dot node, and then you can find its immediate child in that stack. And you can find children by IDs that you provide them when you create them in the stack. So you can see the ID that I provided to my custom construct was custom construct, custom underscore construct. So I'm saying that in my stack, find this child. And so this function returns undefined if it cannot find this child. If it can find the child, then it returns the child. So I'm saying expect this thing, try to find child, and expect this function to not return undefined, because I'm expecting that there's a child with this ID in my stack. Yeah, because this is the idea that we gave to our custom construct. So this should work fine. So now we're restricting our tests to our immediate children. We want to know that what are our immediate children of our stack. Here it was going through resources. It was checking resources not only in the immediate children but everywhere below the stack. But now I'm restricting my test. I'm saying that I only want to look in the immediate children, whether this thing exists in my immediate children or not. So you can see it does, and we know it does because we created it over here in this scope of the stack. Okay, now, and likewise, we also expect our lambda function to not to be undefined. Why? Because our lambda function is also the immediate child of our stack. You can see over here, and the ID is test lambda. So that is what we are passing over here. It should also be undefined, which means that this lambda is also the immediate child of our stack. So you can see we are now actually identifying what are the immediate children of our stack. So we have up till now we have identified that this is the immediate child of my stack and this is the immediate child of my stack. You can see the second test also passed. Now, if I try to run this same function with the lambda that was made inside my construct that was made over here, that it is called test lambda. Now basically I'm in the function I'm passing the ID of this lambda function, which is not the immediate child of the stack. So it should return undefined because this function only looks for the immediate children of the stack. So you can see in the condition I'm saying I've removed the not. I'm saying it will be undefined. This is really important to understand. This is how you can actually verify that whether your resources are being made properly within the right scope. You can see it passed. So now I'm pretty much sure. I'm very sure that these two were made in the scope of the stack, and this lambda is not in the scope of the stack. Yeah. So now I'm very sure that my application is working just as I made it. So this was a bit advanced test. Now let's move on to the last test. Let's say if I go to my construct, this is my custom construct in which I just have one lambda function. I'm over here. Now if I also add a DynamoDB table over here, but if you notice it, if you look at it closely, you can see in this scope I have not passed this. I have passed the value that is coming from the constructor. And what is coming from the constructor? In the constructor, we're getting the scope of the stack. So what does this mean? This means that although the code for this DynamoDB table is being written in my custom construct, it will be created within the scope of the stack. Why? Because the scope that we have passed over here is coming from the stack. Yeah, you can see over here the scope that is coming in from the constructor. We have passed it over here, and that is the scope of the stack. So this means that over here in our we're creating a DynamoDB over here as well. This may look confusing because the code for this DynamoDB is inside this custom construct. But because in the scope, we pass the scope of the stack, it would be made inside the scope of the stack. This is really important to understand. You need to know this to write the tests. Otherwise, you won't be able to write the tests. So now we can actually test that whether this DynamoDB table was made inside the main stack or not. So you can see again, I initialize my app and stack. Now in my stack, first of all I'm going to count the resources of type DynamoDB table, and I'm expecting only one DynamoDB table, right? So this test, I told you before that this test works, looks for resources not only in the immediate children but everything below the stack. So it will look for DynamoDB table here, 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 here. So although it's although it's gonna pass, if I like comment it out, even if this test passes, we're still not sure that where was this DynamoDB table made, because it could have been made over here as well. We are still not sure, and this is not a good testing. You need to be exactly sure where was this DynamoDB table made, because right now we just have a very small application. In reality, you can have like a huge tree, and you need to be exactly sure that where a particular resource was made. So you can see it passed. So right now we just tested that, okay, we have one DynamoDB table somewhere over here. But now if I use the other function that I showed you before, try find file, and this is more specific. Now it will only look for DynamoDB table over here in these three constructs. If it can find it over here, then it will not return undefined. It will return the node of the DynamoDB table. But if it cannot find a DynamoDB table within these three constructs, it will return undefined. And so the ID that I gave to the table was table. Let me confirm it. You can see it's table. In some, I want to find the child within the scope of the stack, and it should not be undefined. Like it should be there. So you can see it passed. So this actually verifies that our DynamoDB was made over here, not over here. Yeah, so I think that's it for the testing. I have tried to cover as much as I could, but this is just, I think, scratching the surface. There's a lot more that you can do with testing.
Both you and Homan did a very good job, and at least I understood it. I don't know about other people. I learned a lot. Okay, see you guys in the next class. Thank you so much. Bye-bye.
Okay, bye-bye.